Okay, so we are going to be taking the second example on mixed design. So the question says determine the concrete mix ratio using the BRE concrete mix design method. Given the following water cement ratio, is 0.55, free water content for fine aggregates and coarse aggregates are 160 kilogram per meter cube and 190 kilogram per meter cube respectively. Wet density of concrete is 2,440 kilogram per meter cube, and proportion of fine aggregate is 38% for a 20 millimeters maximum aggregate. Okay, so whenever we are given this problem, so the first thing we do is to get down our parameters. So the question says using BRE method, which is Building Research Establishment method, and it was derived from the UK. So the given parameters, we have the water cement ratio to be 0.55. We have the fine aggregate free water content to be 160 kilogram per meter cube. The coarse aggregate free water content to be 190 kilogram per meter cube. We have the wet density of the concrete to be 2,440 kilogram per meter cube, and the fine aggregate proportion to be 38% for 20 millimeters maximum aggregate size. Okay, so we have gotten all the parameters in the equation. So the first thing we do is to find the total free water content. Okay, so we have free water content. So be equal to, is giving us 2/3 of the free water content for fine aggregate plus 1/3 of the free water content for coarse aggregate. So we have this to be 2/3 times the free water content for fine aggregate is 160 plus 1/3 times the free water content for coarse aggregate is 190, and this gives us what? 170 kilogram per meter cube. Okay, so after determining the value for our free water content, the next thing we determine is our cement content. Okay, so our cement content is giving us our free water content, which is also our water content, divided by our water cement ratio. Okay, WC ratio, and this is equal to our water content, which is 170, and this is in what? Kilogram per meter cube, divided by our water cement ratio, which is 0.55. Because it is a ratio, it has no unit. Okay, so 170 divided by 0.55 will give us what? So we have 170 kilogram per meter cube divided, so 309.09 kilogram per meter cube. Okay, so we have gotten our free water content, we have gotten our cement content. The next thing we determine is our total aggregate. So our total aggregate is equal to the wet density minus our water content minus cement content. Okay, So our total aggregate is equal to, our wet density is given as 2440 minus our water content, which is given as 170 minus our cement content, which is given as 309.09. Okay, so our total aggregate is given as what? 1960.91 kilogram per meter cube. Okay, so we have gotten the total aggregate. Now we know for our mix design, we have our cement, we have our fine aggregate, which we can also call sand, and then we have our what? Coarse aggregate, which we can use granite. So we need to get the weight. This is the total weight of aggregates. We need to get the weight of the fine aggregate and the weight of the coarse aggregate. So how do we get that? From the given problem, we have that the proportion of fine aggregate is what? 38%. So in this total aggregate weight, which is 1960.91, fine aggregate occupies what? 38%. So to get the weight of fine aggregate, so weight of fine aggregate FA is equal to 38/100 times the total weight of aggregate, which is 1960.91, and that's equal to 745.16 kilogram per meter cube. Okay, so the weight of coarse aggregate, is simply going to be what? The weight of the total aggregate minus the weight of what? Fine aggregate. So it's going to be 1960.91 minus 745.16, and that's going to be equal to what? 1215.75 kilogram per meter cube. Okay. So we have gotten the weight of coarse aggregate and the weight of fine aggregate. Now, in the given question, we were given that we had a maximum aggregate size of 20 millimeters. Now, for a maximum aggregate size of 20 millimeters, so for a maximum aggregate size of 20, okay, so whenever we are given a maximum aggregate size of 20 millimeters, we use the ratio of fine aggregate to coarse aggregate to be 1:2. Okay, so we add this ratio, 1 plus 2 is equal to 3. So considering the maximum aggregate size to be 20 millimeters, for fine aggregate is going to be equal to 1/3 times the weight of our coarse aggregate, which is 121.75. 121.75. 1215.75. And that's going to be equal to what? 405.25 kilogram per meter cube. And then for coarse aggregate, is going to be 2/3 of the total weight of coarse aggregate, which is 1215.75. and this is going to be equal to what? Eight 810.50 kilogram per meter cube. Okay, so after getting this proportion, which is based on the maximum aggregate size of 20 millimeters, the final thing we do is to determine the mix design ratio. Now, to get our mix design, we simply divide every other weight, which is the weight of fine aggregate, coarse aggregate, and the weight of cement, to the weight of our cement. So for the cement, we have, so what's our weight of cement? So this is 309.09 divided by 309.09. This is in kilogram per meter cube, and this also is in kilogram per meter cube. So this takes out this, and we have this to be what? 1. So after getting the weight, the ratio for cement, which is always 1, because we divide every other weight by the weight of cement. So the next ratio to determine is that of fine aggregate. So for fine aggregate, which is also given as our sand, this is equal to the weight of fine aggregate 745.16 all over 309.09. This is in kilogram per meter cube, and so is this. So they cancel out. So we have this to be what? 2.4. So to get our final ratio, which is for coarse aggregate, which can be considered to be granite, we have this to be equal to the weight of coarse aggregate divided by the weight of cement. So this is equal to 1215.75 all over 309.09. And this is equal to what? So this is equal to 4 point. So this is equal to 3.9. Okay. So we have our mixed design ratio to be equal to 1:2.4:3.9. Okay.